This morning we're trying to show that the sum of the first 75 cubes is a multiple of 6. So let's just take a look at the first three to kind of a sanity check on this thing. So 1 cubed plus 2 cubed, I'm just doing the first three, plus 3 cubed, okay, is equal to what, 27 plus 8 is 35, 36, which of course is equal to 6 times 6, right? So it's certainly a multiple of 6. So it's true for n equals 1 to 3, but I want to show that it's true n equals 1 to 75, and proving this will be equivalent again to showing that the numerator is a multiple of 6, because then that 6 will divide out and it'll be a natural number. Okay, so let's move along. Now this is a super useful result right here. This lemma n cubed is congruent to n mod 6. You can prove this very easily by just checking n equals 0, 1, 2, 3, 4, 5. Or you can, there's another proof I'm going to give you that's a little more direct and not a modular arithmetic based proof. I want you to notice though that this statement right here, n cubed is equal to n plus some multiple of 6, is certainly equivalent to n cubed minus n equals to some multiple of 6. Okay. Now, here's the proof. So n cubed minus n factors into n times n squared minus 1. N squared minus 1 is n minus 1 times n plus 1. If you rearrange, you get 3 consecutive integers, right? You get 3 consecutive integers. N minus 1 times n plus 1 is the product of 3 consecutive integers. The product of any 3 consecutive integers has to be a multiple of 3. So we can quickly write down equals to 3 times, now also the product of 2 consecutive integers all over the place here, n times n plus 1 or n minus 1 times n. One of these has to be even, right? So we have 3 times 2 times some, we'll say k, all right? So you see that proves it. And again, you can prove it modular arithmetic by just checking the remainders 0, 1, 2, 3, 4, 5 in the original, and you'll always get that it's a cube is congruent to itself mod 6. Now, not to itself, but to the base of, n cubed is congruent to n. But anyway, so we've proven this lemma, n cubed is congruent to n mod 6. And so you see it's fairly easy at this point. See how n cubed gets replaced by n right here? Okay, n cubed gets replaced by n per the lemma, right? Per this lemma. All right, and so this part right here, now this is the sum of the first 75 natural numbers. They're called triangular numbers, and their product is, the product in this case is 75 times 76 over 2, the famous n times n plus 1 over 2. Okay, now what I'm going to do is just reduce this, and we're going to show that this is 0, which will show that n cubed is a multiple of 6. If n cubed is congruent to 0, that means 6 divides n cubed minus 0. It means 6 divides n cubed, means n cubed is a multiple of 6. Now, so let's move along right here and get this done. Okay, now I'm going to write the congruence symbol here, not the equal symbol. You see, this is just the triangular number result. Now we're interested in congruence mod 6. And so if you divide 6 into 75, you get a remainder of 3. You see, that's why they call this a remainder arithmetic. If you divide 6 into 38, you get a remainder of 2. That's equal to 6. Which is trivially, and I say that not pretentiously, is trivially congruent to 0. Okay? So we've shown here that this summation n equals 1 to 75 n cubed is congruent to 0. Okay, but remember, that's the very same thing as saying that it is a multiple of 6. Exactly the same thing as saying it's a multiple of 6. Okay, so that proves it, QED. And of course, the modulus is understood to be 6. Okay, now, so what we've really shown here, if you really want to just finish this thing, we've shown that the numerator here is equal to 6m. Okay, so done. All right, thanks for viewing.